Alright, for those of you that missed when we went over the frame on sequences, here you go. So I'll have the PDF up on the website as well, so you can download it. Okay, so our key topic is sequences. Okay, sequences are just the patterns, and we've been looking at how they grow. And that's the essence of math. That's what math is all about, these patterns and taking them and doing stuff with them. So, the first pattern we were talking about is arithmetic. Okay, remember, that's when we're adding or subtracting by the same number each time. Okay, so we've got our recursive example. Right here we've got f of n equals f of n minus 1 plus 1. That plus 1 is what tells us it's arithmetic. Okay, remember, with recursive, that part's always the same. Now, there's a second part to our recursive example, because with just this piece we don't know where to go. We don't know our previous number, so you have to give it a starting point. So that's what this f of 0 equals 3 means. Okay, that's the starting point. That's the first part, and then using this we can go down here with that on the table. Okay, the explicit, we've got that slope-intercept form equation. The m stands for the growth, the b the y-intercept, or the starting point. We often think of it as we have our starting point, then we add the growth to it. And when we make a table of it, it looks like this, right? Our growth is what we're adding or subtracting by. The starting point is when x is 0, it's whatever the y or the f of x value is. So we can make an equation for our variable by going y equals our starting point. Then what did we do to it? We added 3. How many times are we adding 3? We don't know, so that's why we multiply by the x. And this is very important right there. The variable is multiplied by the growth. It's very important when you're talking about an arithmetic. If we graph it, we get our straight line, which we often call those linear. Okay? Now let's back it up to geometric. So for geometric, okay, for this one, now we're dealing with multiplying or dividing by the same number each time. Okay, once again, our recursive equation, f of n equals f of n minus 1. Remember, that's the next term output is equal to the previous output, and then in this case, times 4. We also need that starting point, tells us where to start. So we can make a table and actually use the pattern to come up with our numbers. Now, the explicit example, it's kind of like a slope-intercept form for geometric. Okay, our y-intercept, or our starting point, is a times our growth, our b. Okay, so the same basic idea, because we're multiplying, we have some different aspects to it. So in a table, our growth, we can see it by either multiplying or dividing. Our starting point is still the same, where x is 0, the y or the f of x, that number is where we go. So if we're making an equation for x, we go our starting point, 2, times what our growth is, 2, and then remember, repeated multiplication, when we do it over and over and over, we can shortcut write it with a power. So that x is in a power, whereas this one was multiplied because that's the shortcut way of repeated addition. So we got to remember, for geometric, the variable is an exponent on the growth, whereas arithmetic, you're multiplying the variable. So when you graph it, you make this curved graph, which we often call exponential. Okay, and these both help us model situations in the real world and in math, and that's why they're important. Okay, so if you need to, pause and write any of this down. The other side, or the second page, is about those two types of equations that we talked about. So we've got recursive, which models this same idea most of the time. These are usually numbers. Okay, the n stands for our input. So if you make a table, that n is this number, but it's just in reference to the output. Okay, that's what we're really looking for. So f of n is our next output. F of n minus 1 was the previous. We connect the outputs. So the number here, we connect this number to this number, this number to this number. That's what we're doing with recursive. Okay, and the reason we do that is because it models the way we think about patterns. If I give you a pattern, you automatically use what you know to help you find what you need to know. Okay, that's the way our minds think about patterns. Now with explicit, we've got, in our two cases, a slope-intercept form, the form for the geometric as well. So it's our starting number and our growth. The x stands for our input, the y or f of x is our output. So it connects an input to an output. This is why explicit is useful. Recursive works when we've got a pattern and trying to find the next number. But if you try to go ahead and find numbers even further, that makes it more difficult. That's where explicit comes in. By the way, this is a 2. So it says there are 2 main ways to write equations. But with explicit, we can give you an input, and using the pattern, what we found out about the pattern, you can then take it to find the output. Okay, so it helps us skip ahead. Okay, and that's just a way for us to understand patterns, which is a good way of understanding. That's the basis of math here. So recursive and explicit equations, we need to know how to write those. You need to make sure you understand the difference between arithmetic, geometric, and how to write their equations as well. So there we go. I hope this frame will be helpful. Remember, a frame is just some concentrated notes that you can use as you're doing your homework, as you're getting ready for the test, so that you can do better.